Hi everyone, welcome back to Dave's Math Channel. This is my continuing feature on the Math Lovers book, which I show in this slide. It's actually a 3-volume series. Might as well give another plug for it. I'm starting a new chapter today. I'm starting chapter 6, which is on group theory. In volume 1. That's the volume on the left. This is the more recreational volume. There's a total of 10 chapters in this book. I've already gone through the first 5, so I'm halfway done with the first volume already. And starting the second half. Pretty exciting new topic I'm starting today on group theory. You'll see that it's a very interesting as well as a very important area of math. Anyway, I think we'll have a lot of fun with it. And then the second volume is a little more academic. It's on more academic topics like functions and calculus and probability and statistics. And I'd say it's a little more advanced too. I would say that volume 1 is sort of, maybe junior, senior high school level. I'd say volume 2 is more like first or second year college level. And volume 3 is just problems and solutions pertaining to the first 2 volumes. And these are all available on Amazon.com in case you're interested in purchasing them or any combination. And I believe they're $40 a piece paperback or $100 for the whole set. Or you can buy them in Kindle for $20 each, I believe. I'd have to look up the price, but you can find them on Amazon either by typing the Math Lovers book or my name, David Teer, in case you're interested in purchasing any of these. If not, you can watch my series, which I'll probably be doing for a while. I've been doing it for about probably 3-4 months already. But anyway, like I said, we're starting a new section now, a new chapter on group theory. So I'll start with the very basics. What is a group? Anyway, let's begin. This is just the introduction to my chapter. Why do we care about groups? I mean, before I even say what they are, they have a formal definition with 4 axioms. But for now, I'll just tell you that groups are a special type of set. Chapter 5 was all about set theory, and I talked about sets ad nauseum. Sets, sets are important, but I don't think they're that interesting in and of itself. I mean, maybe that's just my personal opinion, but I think groups are a lot more interesting. They're a special type of set, but they have additional structure. I mean, sets are really just kind of collections of objects, but groups are sort of structured collections of objects. And the structure is very important because the structure gives rise to symmetry. And really, group theory is really the way you're supposed to think about group theory. Group theory is the mathematical theory of symmetry. So I think you guys all know about symmetry. I mean, every time you look at a mirror, that's basically symmetry. Your mirror image is a reflection of you, and there's symmetry between you and your mirror image. And some pictures, some images have what's called bilateral symmetry. Most people's faces are pretty close to symmetric, meaning that if you put a mirror over half of your face and showed the mirror image of the other half, it would pretty much look the same as your face. And a lot of people think that, more attractive people have more symmetric faces. We do seem to like symmetry biologically. I'm not going to go into that right now, but there's other reasons to be, symmetry is really at the heart of physics too. It's not just for aesthetics. It's not just for like art or, looking at beautiful people. It's also, very important in physics. Symmetry, there's the thing called Noether's theorem, which says that all the laws of, or at least the most important laws of physics are all consequences of various types of symmetries of the universe, like symmetry in space and symmetry in time. So symmetry is very, very important and is very, very powerful. And there's a lot of different types of symmetry, not just bilateral symmetry. So, and the mathematical theory that you use to describe symmetry is group theory. So that's kind of a nutshell why group theory is. But now I'm just going to go into what is a group. So now I hope I've at least whetted your appetite a little bit for group theory. You might wonder what a group is. Well, a group is a set with an additional, it has what's called a binary operator, which is usually called group multiplication. But you're not really supposed to think of it like ordinary multiplication, although it can be. For certain types of groups, it could be just like multiplying numbers. But in general, you're just supposed to think of it as an operator. And sometimes group multiplication is actually addition. So it's a little confusing because group multiplication isn't always strictly multiplication the way you guys probably think of it, but it's a binary operator sort of like plus or times that works between two elements of a group. So like I said, a group's a set. It has a set of elements. And, so the first, then there's 4 axioms. Sometimes people just write 3. Sometimes people leave out the first axiom, which is closure. I like to include it. So closure basically just says that if you have any 2 elements, A and B, in your group, which we usually denote by a capital letter like G. So just A and B are any 2 elements. Remember, a group's a set. It doesn't have to have 2 elements, but if it does, and A and B could be equal, by the way, then the product also has to be in the group. So A times B, the group product of A and B, is also an element of your group. That's all it means to say that your group is closed. So every group has to have this property, closure. And then the second property, this is like addition and multiplication, ordinary addition and multiplication, associativity. It just says that the order in which you multiply 2 elements, or 3 elements, the order in which you group the elements doesn't matter. So in other words, if you have 3 elements, A, B, and C of your group, if you multiply B and C first, so you take the product of A with the product of B and C, you get the same thing as if you multiplied A and B first. You take the product of A and B and multiply that by C, that gives you the same thing. And I think you guys know that ordinary addition and multiplication of just ordinary numbers is associative. Well, it's true for elements of a group as well. And then the third property is identity. And what that says, there's a special element of your group, which we usually denote by the letter E. Sometimes people write 1, but more generally you write E. There's a special element of your group E, such if you multiply it by any other element of your group, it doesn't matter whether you multiply to the right or to the left, say your element's A, then E times A is equal to A times E, and that's equal to A. So it acts like 1. It just acts like, the identity element. It's called the identity element of your group. And then there's one final property of elements of a group, that's called inverse. So if A is any element of your group, there's a unique element called its inverse, which we write as A with a superscript of -1. You can think of it as 1 over A if you like. And then it has a property, if you multiply either on the left or on the right by A, you get the identity. So A times A inverse is equal to A inverse times A is equal to E. So any set that has this operation, this binary operator, which we call group multiplication, that satisfies these 4 axioms, is a group by definition. And I know that's kind of a mouthful. I mean, this looks very abstract right now. A lot of people kind of get turned off when they first see this. But, maybe I'll show you another slide. This is just the same thing I just said. This is probably easier for you guys to see, especially if you're watching on your smartphone, which I think most people do. I prefer using computers, but I think nowadays most people surf the web or watch YouTube videos on their smartphone. Just because everybody has them, and not everybody has a PC or a laptop, and even if you do, you probably don't take them with you all the time. So this will be easier for you guys to see. Hopefully you can see this slide, but basically it just says what I just said. And I think they use a little bit different notation here. They're using star. This is a little more common notation, star or asterisk for group multiplication. And like I said earlier, asterisks can be a lot of different things. It's just any binary operator as long as you get these 4 axioms. So those are, once again, the axioms of group theory. And any set with this binary operator, which they're calling asterisks here, that satisfies these 4 axioms is a group by definition. And I guess I just want to say one more thing. I think I already said this, but Don't take this too literally. Even though they talk about group multiplication, like I said, it doesn't have to be multiplication the way we ordinarily think of it. Sometimes it could be addition. They're what are called additive groups. As long as it satisfies those four axioms, we can use whatever symbol we want for this binary operator. And we will see examples where we'll use plus instead of star or times. So it depends on what the group is and, kind of what kind of things we're describing here. And, right now I haven't given you any specific examples of groups yet. I think once we see specific examples, this will become a little more concrete. It probably won't be so mysterious. I think there's just one more thing I want to say before I finish. Notice that commutativity is not one of these four properties. As a matter of fact, there are some groups that are not commutative. We do have groups where group multiplication is not commutative, meaning there are elements A and B here. They're using X and Y. I guess I can stick with X and Y here. There are elements, there are certain groups where B times A is not necessarily the same thing as A times B. Those are called non-abelian. If the group has commutative group multiplication, we call it an abelian group. And both abelian and non-abelian groups are very important, and we're going to study examples of both of them. Non-abelian are a little harder to work with, but they're just as important. As a matter of fact, I think some of the most interesting groups are non-abelian. So anyway, I think that's a brief introduction to group theory. Thank you for watching. Long live math, and I'll see you guys next time. Bye.